When we enter chapter 8, we are going to use a lot of facts and concepts that we've already learned. So we are going to be using a lot of factoring. We are going to use fraction rules. We are also going to use eventually roots and higher roots. So it's really important that we refresh some of these ideas prior to starting the content on rational expressions. So here we go. We're going to take a look at factoring. I have a couple rules here that we always want to take out the GCF first, the greatest common factor. We want to factor each completely. So the first set of problems we have are factoring by grouping. So the first thing I want to do is I'm going to take a second and rewrite this problem. And I'm always looking for a GCF, so I look at all four terms, and there is not a GCF for all four terms. So the next thing I'm going to do is I'm going to go ahead and come in here and factor by grouping. So whenever you factor by grouping, there's a couple rules. You always group the first two, keep the plus sign in between, and group the second two. Okay, and the next problem we'll see there's a minus sign, so we'll address that. So always group the first two plus the second two. We don't want to turn this into multiplication. And then it's really simple. When I see that I have four terms and there's no GCF, there's no other nice way of doing this. So I go ahead and I factor by grouping. So again, you group the first two, the second two, and then you're really doing two simple GCF problems. So I'm going to look at the first set and see what they have in common. They both have a 2a squared that I can pull out, just like a GCF. I'm ignoring this part and just taking this out. What's left once I take that out is an a plus 7. That's it. Now, when I look at the next set, I bring my plus sign down. The GCF of these two is 5. And when I take out the GCF of 5, what's left is a plus 7. So if you take a minute and look, it's a little abstract, but I have two terms, 1, 2. And these two terms have the a plus 7 in common. So just like a GCF, I'm going to pull this out, a plus 7. I like to pull that out first, keep it in parentheses. That is the GCF. And then what's left is 2a squared plus 5. So let me talk about this again. When we did the GCF here of 2a squared, we took that out. We pulled the 2a squared from here, and we pulled the 2a squared from the other one. And we said, okay, once I pull that 2a squared out, that's a common factor. And then what's left is the a plus 7. So it's the same idea. When we pulled the a plus 7 out, it's not squared. We divided it out of this one and this term. And then what's left is 2a squared plus 5. And if you take a minute and look at this, this is my final answer. Double check that there's no GCF left that I missed. If I would take this a plus 7 and I would distribute it, I would get a plus 7 times 2a squared. And then I would take the a plus 7 and distribute it to the 5, and I'd get the a plus 7 times 5. So, final answer, 2a squared plus 5, a plus 7. I have it in the other order, and the order doesn't matter because multiplication is commutative. Okay, looking at our next example, the first thing I do see is that I do have a GCF, and that GCF is 2, and then I look a little closer and I'm like, oh, I think I can go higher, I can go to 4. So the first thing I noticed, they were all even, so I wanted to use a 2, and then I tested to see if I can go higher. They also have in common a u, so I'm going to take a u out of everything. Now, I like to put this part in brackets to isolate it. I'm going to have a 35 uv. So again, everything's just being divided by a 4u. And then I have a plus 5u minus 7u squared minus 25v. Put my brackets there. Okay, now that I've taken out the GCF, what I think is a GCF, I'm going to double check it. 35, 5, 7, 25. Okay, all of these have a 5, but the 7 doesn't, and there's no GCF then. So I'm going to go ahead, I'm going to group the first two, but if you remember I told you there always has to be a plus sign in the middle. So if I squeeze this and I put parentheses around here, that looks like I'm distributing the negative sign. So what I'm going to do is I'm going to squeeze that minus sign in there, so the negative is still with the 7, just like a minus 7. I'm going to put a plus sign in the middle myself. Okay, next idea, I don't want to lose my GCF. It can't be lost, so we're going to keep it. And that's why I like the bracket, so I can differentiate that in my parentheses. So what do these two terms here have in common? They have a 5u in common. What's left? 7v plus 1. And that's one of the mistakes we make, is we forget that 1. So if I have two terms, I should always have two terms to redistribute and get my 5u. I'm going to bring down my plus sign, and these two don't have anything in common right now, and I'm stuck here because the 7 and the 25 don't have a common term. So I thought I could do something with this, and I'm stuck. This one went well. So it's not that I can't factor, it means that I need to reorganize it. So I'm going to leave that 4u alone, and this time I'm going to go ahead and pair the 35 and the negative 7 together, because then I know they have something in common. The 35 and the 5 had something in common, or I could do the 35 and the 25. But the 35 and the 5 did not work because it left me a bad combination here. So I'm going to go ahead and redo this. I'm making a 35 UV. I'm going to swing that 7 over here, and then plus 5U minus 25V. So all I did was rearrange. I left the 4U there. I just paired up the 35UV and the negative 7U squared, and then I have the 5U and the negative 25V. So no signs have changed. I found out that this did not work. Now, you wouldn't know that ahead of time. You have to try it sometimes. So I'm going to do the same thing. I'm going to group it. This time I have a plus sign in the middle, so that's good. And then I'm going to come back and rework it. So I have a 4U bracket. What comes out of here is a 7U. What's left is a 5V minus U. Okay, get my parenthesis there. What can I take out of here? Well, I can take out a 5. Now, when I take out that 5, I'm left with a U and a negative, change colors here, I'm left with a U and a negative 5V. And so I'm looking at that and I'm having a little problem, because what I want is for what's in parentheses to be the same. And I have a positive 5V and I have a negative 5V. So that means I should have taken out a negative 5. And by taking out a negative 5, a negative times a negative would give me back my positive 5u, and a negative times a positive would give me back my negative 25. So now, even though they're out of order, I have the same thing in parentheses. So I've got my 4u out here. What I have in parentheses is a 5v minus u. Again, there it is. And what's left over is 7u minus 5. We want to double check that we have it fully factored. There was nothing left over. And that is our final answer. And again, it seems like the answer key for these worksheets always have it in different order. We both have the 4u. I have the 5v minus u first, and they have it in the other order. All right, let's move on to another problem. We have factoring trinomial. So that was a review on factoring by grouping. And now we're going to get into factoring trinomials. So the first thing, again, this time I see I have 3 terms. It doesn't matter what you're given, how many terms it has, I'm always going to look for a GCF. And in this problem, I have a GCF of 5. So we're going to take that out. And what's left is n squared plus n minus 6. Okay, so now that I've gotten that, this is your basic quadratic trinomial, and what's nice is that a, the number in front of n squared, is 1, and that makes factoring easy. So I'm just going to go right into reverse FOIL. So my first term is n times n. My last term is a negative 6. I want factors of negative 6 that add up to 1n. There's a 1 there and a 1 there. And so this is my outside and inside. So again, this is all a review. We spend a lot of time on factoring, but it's good to put this back into perspective. So we need factors of negative 6 that will add up to positive 1. So first I thought negative 3 and 2, that multiplies to negative 6, but it adds to negative 1. So I want it to be a positive 2 and a negative 3. Just switch my signs. Other factors of 6 are 1 and negative 6, or negative 1 and 6. This is the set that adds up to 1. So I just have to plug it in, plus 3 minus 2. Now how do I check this? That's my answer. I'm done. But I want to double check, and this is important later when we have to do trial and error. The n times n is n squared. The outside gives me a negative 2n. The inside gives me a positive 3n, and there's my 1n. And last, 3n times negative 2 is negative 6. So it's always good to do a double check. All right, next problem, we have 21n squared plus 159n minus 270. And what I see is they have in common a 7. I'm sorry, they have in common a 3. And that leaves me a 7. So I'm going to take out the 3. And what's left is a 7n squared plus 53n minus 90. Okay, now this one is harder than the one we just did. Okay, I always call this the easier factoring because a is 1. But when a is not 1, we have some work to do. So we have to play with these numbers a little bit. So I'm going to jump in, and I always recommend a pencil, which I don't have right now, but I always recommend jumping in and setting up your 2 sets of parentheses. And this is my first term, my outer, my inner, and my last. So my first term, the only options are 7 and 1. There are no other options, just 7 or 1. So I'm confident to put those here in pen. But when I look at the number negative 90, my last term, there are a lot of things that I could use. I could use negative 9 and 10 or positive 9 and negative 10. And I don't normally list all the signs. I could use negative 3 and 30. I could use positive 3 and 30. I could use 15 and I could make a positive 15, and then we have to see what we get. 6 here, or negative 6. Well, if I use 10, I could use 5, okay, or positive 5, and that would be 18 or negative 18. I could use 2 or 45, negative 2, 45, and I think I've got most of them. I might be missing one of the factors, but I've got a good start here. Okay, I am back with a pencil because we have some trial and error to do. So the first thing I'm going to do is I'm going to put my negative 9 here and my positive 10. And I'm going to see if that works. So how do I check it? These are all my options for the last number. The question is, do I have the right combination to give me the proper outer and inner when I multiply? So my first term's set. My last term, all of these options give me negative 90. My question is, did we get the 53 when I multiply the outside and the inside? When I multiply the outside, I get a positive 70n. When I multiply the inside, I get a negative 9n. Well, that gives me 61n, not 53. Okay, now, I'm not going to do this again, but right now I'm going to show you. If I change my signs, and all I do is change my signs, that doesn't change much. I now get a negative 70 and a positive n, and so instead of getting a positive 61, I get a negative 61. So I'm telling you that the sign is the easy fix. If I get the right number and the wrong sign, I just switch my signs. Unfortunately, I got the wrong number, so the signs don't matter. So what I'm going to do is use my eraser, which I wish was a little better, and I'm going to flip. So I had 9 and 10, I'm going to make it 10 and 9, and I'm really not worried about the negative sign. So now I have my 7 times negative 9, which is negative 63, and I have 10 times n, which is positive 10 with an n, and that adds up to negative 53. So what I found is I have the correct number, 53, I have the wrong sign. So that is a simple fix. Wrong number, switch your numbers. Wrong sign, switch your signs. And so now I have a positive 63 and I have a negative 10, which gives me a positive 53n. Okay, now that worked on my second try. That you see, I could have been here for a long time. So if my numbers don't work, I flip the numbers because the 7 times that is different than if it was 7 times 10. If these numbers didn't work and I've tried them both directions, then I would start by trying the 3 and the 30. Again, I don't have to try both signs. I just need to try the numbers and flip the numbers. If it doesn't work, throw it out. If I get the right number, wrong sign, simply switch your signs. All right, this video is already 13 minutes long and we've only done 4 problems, so I'm going to start moving a little faster now that we've laid the groundwork for reviewing. And again, you can always skip through the video to see what you need. You could try the problem, and if you get it right, then you can move to the next problem. All right, so I've got this problem here. It's negative 36 n to the third plus 72 n squared. And I was looking at this, and I noticed they're both even, so I can take a 2 out. I could take a 4 out. I could take a 9 out. And then I kept trying, and I found out that I could take out a 36. Now, I'm choosing to take out a negative 36 and an n to the second. So I like to always try the smaller number. Does a smaller number work? If not, start breaking it down. So the smaller number was actually my GCF. What's left here is a positive n and a negative 2. And that's it. If I redistribute this, I get back to where I was, and there's nothing else I can do here. That is factored completely. If you only took out a 36n squared, you'd be left with a negative n plus 2. Either answer is correct. This is just the more proper answer. All right, so we have another problem here. We have a 9u to the fourth, a negative 39u squared, and a plus 30. And so what I see on this problem is that I do have a GCF of 3, okay? So I'm going to go ahead and use that GCF of 3. I'm going to take that out, and I'm left with a 3u to the fourth minus 13u plus 10. And so my problem with this is the fact that I have a higher power, okay? But that's okay. It didn't come out as a GCF. I can still work with this. So I'm going to keep this 3 out front, and I'm going to break this down. Now, same thing. I'm really reversing FOIL, but I have to do some trial and error. My only options for 3 are 3 and 1. So I'm going to go ahead and set those. That's sort of the easy part. And then I have to look at 10. So 5 and 2 or 10 and 1. Those are my options. Now, if I put a positive and a positive here, I end up with a positive middle number. So if I have a positive 10, I need a plus plus or a minus minus, and I'm choosing the negative signs. All right, back to my pencil. I'm going to go ahead and put in my negative 5 and my negative 2 and see if that works. So I'm going to test this. The outside is a negative 6u squared, and the inside is a negative 5u squared, which adds up to a negative 11u squared. So that doesn't work. So the next thing I'm going to do is I'm going to flip that and make it a 2 and a 5, and we'll see if that works. So I now get a negative 15u squared and a negative 2u squared, which is negative 17. And I just caught an error here. I should have a 2 there. All right, so that doesn't work. So I'm going to throw out that set, and I'm going to try the 10 and the 1. Now, I was looking at this trying to decide what I wanted. If I put the 10 here, that's going to be too big. It's going to be 30. So I'm just going to try the 10 here. And then we get 3u squared times negative 1 is negative 3u squared. And then negative 10 times u squared is negative 10u squared. Fabulous. I got negative 13u squared. Now, a lot of times we would be done and we would walk away from this problem. But I keep mentioning to look and make sure that it's factored completely. All right, so we've got this factored. But this problem is not factored completely. And what's sticking out is not that there's a GCF. There's definitely not a GCF. But I still have a power of 2 here. And we didn't see that in the other problems. And so I want to look and see this does not factor. Okay? This does, and we're going to talk about this in a little bit. This is the difference of squares, which we've already covered, and this does factor. There are factors negative 1 that add up to 0. So you have a u squared plus 0u minus 1. That's truly what this is, okay? So I'm going to keep my 3u squared minus 10. Try as I might, that won't break down. But this does. This becomes u plus 1 and u minus 1. Because factors of negative 1 that add up to 0 are plus 1 and minus 1. All right, so that is my final answer if I want full credit. It's also really important in polynomials and when you're doing rational expressions with polynomials and rational equations that you factor completely because of how things work out. All right, I said I was going to move faster, and I am not, but I think this is a really important review. All right, so we just talked about a difference of squares, and here we are with special cases. And in these special cases, I have a difference of squares first. And so how do I know this is a difference of squares? 16 is a perfect square, negative 1 is a perfect square, and it literally has to be a difference. So if I wanted to rewrite this again, it'd be 16k squared plus 0k minus 1. So it looks like harder factoring because we have a number out front. We have a coefficient on the square term. However, I'm going to jump in because I noticed it's a perfect square. I'm going to try a 4k and a 4k. So I really can still use trial and error. I can just make it easier. And then 4k times 4k is 16k squared. My last term is negative 1, so I need one positive and one negative to get there. Now the big thing about a difference of squares is that when I multiply, I get a negative 4k, and the inside I get a positive 4k. So we know the first worked, we know the last worked, the outer and inner should add up to 0, and they do. So that is my final answer. Okay, a difference of squares is a tale because you see perfect squares, but you also see that there is a minus sign and there's only two terms. When I see two terms, that's my tip-off. Okay, over here we have maybe a perfect square. It looks exactly like what we were just factoring, okay, a trinomial with three terms. And so again, I can jump right in and do trial and error. That's not a problem. But what I need to know is I can make my life a little easier. So when I go to do this trial and error, there's no GCF. The first thing I'm going to try is the square root of 16. So a 4x and a 4x. And then the 25, yes, there's other factors of 25, but I'm going to try a plus 5 and a plus 5. So the idea is there's other factors of 16. 4 times 4 is what I'm going to try first. If that doesn't work, I can try 8 and 2. I can try 16 and 1. 25, 5 and 5 is what I'm going to try first, but I could also try 25 and 1. I need all positive signs here. Does it work? Well, the 16x squared works. The outside gives me a 20x. The inside gives me a 20x. There's my 40x. And the last 5 times 5 is 25. So you always want to double check it. Final answer though, to get a full credit, we would always take something times itself and write it as a quantity squared. Now, in the chapter coming up on rational expressions and rational polynomials, a lot of times I want to leave this in two pieces so we can see all of the parts. Okay, some more on the back here. We have always to look for your GCF. So we do have a GCF on number 9. They're both even numbers, so they can divide by 2, and we also can take an x out of it. So here we go. We're going to take out a 2x, and what's left is 9x squared minus 25. Now that I've taken that GCF out, I can see that 9 and 25 are perfect squares. So what gives me the hint? Again, there's only two terms, and there is a difference. It has to be a subtraction. It won't work a plus sign. So I'm left with 2x, and then I'm going to break this down. 3x, 3x, a positive 5, and a negative 5. Double check it. Negative 15x, positive 15x. There's my 0. All right, jumping over this one, it jumps back to having three terms. First thing I'm going to do is look for a GCF, and I have a GCF of 5. So if I can take that out, no matter what I'm doing, it's always easier. And you have to do it later, so you might as well do it first. I have an a squared minus 6a plus 9. All right, I have my 5a here. So when I go to take this, I'm going to do a times a. And honestly, this is the easier factoring because there's a 1 out front. The factors of 9 will add up to 6. But I also see I have a perfect square, and it always has to be plus c to be a perfect square. So I'm going to do a negative 3 times a negative 3. I have a plus plus or minus minus option. I need them to add up to negative 6. Again, you'll double check it. Final answer, 5 times the quantity a minus 3 squared. Notice I have a plus sign and a minus sign here, so I cannot, on a difference of squares, write it as a quantity squared. All right, down below, these are good examples because we have higher powers again. And so the first thing we want to do is we want to look for a GCF. And so I do have a GCF on number 11, and that is a 5, and what's left is a 9x to the 4th minus y to the 4th. And it's really important that we pay attention to our powers. I keep my 5 out front. I see that I have two terms, And x to the fourth is a square because I can make it 3x squared times 3x squared. So rather than just x times x squared, x squared. How do I get a negative? There's really a 1 here. I would do 1 positive and 1 negative, and a y times y is only going to be y squared, so I'm going to do a y squared times a negative y squared. And so I get my 9x to the fourth, I get my negative y to the fourth, and the outside is a negative 3, I'll write that down, negative 3x squared y squared, and the inside is a positive 3x squared y squared. And because of that, it cancels. So this is my final answer. Before I finalized it, I did double check because I have an x squared y squared, and so I could keep factoring in this problem. It does not. However, if this was not a 9 and this was a 1x squared and a negative y squared, this would factor x plus y, x minus y. All right, another one of these. First thing I see is the GCF. I really wanted the GCF to be 4, but it wasn't with the 40 and the 8, or 8. It can only be a 2, and I don't see that I can take a variable out, so just a 2. And what's left is 25x to the fourth plus 20x squared y squared plus 4y to the fourth. All right, so this would be a harder problem to factor for the fact that the coefficient of the square term, or in this case the fourth power, is 25. So I have a number other than 1. I also have higher powers here. What makes this easy is the 25 is a perfect square and 4 is a perfect square. So I'm going to try that first. So here's my 2, and I'm going to break this down, and I'm leaving this as a 5, but x squared and 5x squared. And then the last one would be plus 2y squared and a plus 2y squared. Okay, so let's double check that. It seems like everything's working. The outside is a 10x squared y squared, and the inside is another 10, so I get my 20. I'm double checking since I have higher powers. There's nothing that factors, so here's what's left. 5x squared plus 2y squared, quantity squared. That is my final answer. Okay, I hope you're hanging in with me because now we are jumping to something different, and these are cubics, okay? And so this, again, is something that we have learned, but it's one of those things that's easy to forget. When I factor cubics, I'm using a shortcut, and that shortcut has to do with the acronym of SOAP. So you don't have to use this. There is a long way to do it, but SOAP is very helpful. So SOAP stands for same sign, opposite sign, and then always positive. All right, so SOAP helps you set your signs. All right, and why are we setting our signs? Why are we using SOAPs? We are talking about cubics. All right, so we have cubes. We're going to have the sum and the difference of cubes. So I sort of want to do a quick reteach on this because it's one of those things that's easy to forget. So SOAP helps us set signs. Well, how do I know it's cubic? Well, you have to remember that 1 to the third is 1, and 2 to the third is 8. 2 times 2 times 2. And 3 to the third is 27, and 4 to the third is 64. You don't have to remember these, but boy, is it nice to be familiar with your cubic numbers. And I want to say 7 to the third is 343, but I'm going to double check that. Yep, 7 to the third is 343. And I'm going to stop there. But how do I know if a number is cubic? I would take my calculator, and you have to type in a little bit of extra here. So let me move this up a little bit more. There we go. So you need to see that you have a square root key here, and here is your any power, which is your x root key. So I'm going to hit in the 3 in this calculator to tell it I want the third root, and then I type in the x root. So you can see I have 3x root of 343, and it will tell me the answer is 7. Sorry about the light there. Okay, so it's really important that you define it as the cube root of that. There are some calculators that have the cube root. There are some calculators that you flip that order. So that's how I know it's cubic. I'm going to test these numbers. I'm also looking for powers of 3 that you can see are here on the number. Now we also have another way to help us set up a cubic. I had never heard of this before, and I had a friend, a fellow math teacher, that told me they learned this from a college student about doing cubics in the setup. And they said about Santa plowing snow, and I thought, well, that's as crazy as some old horse came a-hopping through my attic for sine, cosine, and tangent. However, I like it, and I added to it. So I'm going to say crazy Rudolph and Santa plow snow. That's what I'm going to put in there. So we're using C, the R, the S, the P, and the S. And here's why. Whenever I have a cubic, I have a to the third plus b to the third. So here is a sum of cubes. And this is how I break down a cubic. I'm going to break it down, and I'm going to have a binomial and a trinomial. So I'm going to have a binomial and a trinomial. Again, this is a shortcut for factoring cubics. Okay, and it's a very useful shortcut. So the first thing I'm going to do is I'm going to use my SOAP acronym. I'm going to use the same sign first in my binomial, and then in my trinomial, I'm going to use the opposite sign. So same sign first, then the opposite sign, and my last sign is always positive. So same sign, opposite, always positive. Now that I have that, I'm using my crazy Rudolph and Santa plow snow. So the C stands for cube root. The C and the R stands for the cube root. So if that helps you, that's the first thing I do is I take the cube root of the a to the third and the b to the third. And the cube root means what times itself 3 times. Gives me a to the third. So the cube root of a to the third is a, and the cube root of b to the third is b. And then the Santa plow snow helps me remember to square, product, and square. Okay? So I'm going to take the first term, I'm going to square it. A to the second. I'm going to take the product of the roots. A times b goes in here. And then the last thing I'm going to do is square the last term. Now, I had never used the Santa plow snow. And again, I added in the crazy Rudolph to try to help you remember that it's a cube root that goes here. The other way to remember it is I do take the cube root, I sort of strip it down to the base here, and then I build it back up. Because a times a squared is a to the third. And b times b squared is b to the third. So just like FOIL, the first times first gives you back your first, the last times last gives you back your last. The last times last gives you back your last. If we would take the time and then distribute all of this, the first and the last would stay, and everything else we multiply out would cancel out in the middle. And that was something that we had checked out before. Okay, so if you want to know what the crazy Rudolph Santa plow snow, if you think that's helpful for your brain, the crazy Rudolph is that you take the cube root of the original sum or difference. And then the Santa plow snow is that you square the first term for your trinomial. You get the product of roots for your middle term, and you square the last term for your last term. Okay, so let's go ahead and we'll use this. Again, that's up to you how you do it. It really is a pattern, and with the sum and difference of cubes, either you know it or you don't know it. So you have to know that pattern. It's a lot of work to do it longhand without this shortcut. All right, so here I have this. If you want to rearrange it, you could, but these are both cubic numbers, so I'm just going to jump in as it's written. And I'm going to do my same sign, so opposite, and then always positive. There we go. I'm going to take the cube root and drop them in. So the cube root of 64 is 4. Double check that if you're not comfortable with it. X cubed would be x. Take the first term and square it. 4 times 4 is 16. Take the last term and square it. There's your Santa plows snow. X squared goes right here. And in the middle is the product of the roots, 4x. The other way I used to talk about it before the Santa plow snow is, again, first times first, last times last gives you back your first and last. And I always talked about when you're in the middle seat of the back of the car, you get smashed. So we just smash these together, and so one time that you ignore the sign. Okay, if you had rearranged it, you might have it as x plus 4, and you would have x, you would still have a negative 4x, and then you would have plus 16. I'm going to double check if it factors further, and it does not. All right, so looking at this, same idea. I see that I have a GCF before I worry about anything else. and that's a 4. What's left is an 8x to the third minus 1, and that 1 is really important there. I see the x to the third, so that's my tip-off that it's a difference of cubes. It's also that there's 2 terms, and 8 is a cubic number. So I have my 4 here, and then I'm going to break it down. I didn't really leave myself enough room here, so let me try that again. So I'm going to break this down, and I have this as a 2x and a 4x squared. Okay, so let me set my signs. Same sign, opposite sign, always positive. Okay, so same, opposite, always positive. Take the cube root, drop it. Take the cube root, drop it. Take this term and square it. So 2x times 2x is 4x squared. Take this term and square it, which is 1. And the product goes in the middle, which is 2x. Again, you actually ignore that sign of -1. Now, this is done, the 4 is done, but I have a power of 2 here. So I would try to factor this, and try as I might, because it looks like a perfect square, 2x and 2x, 1 and 1. This middle term is half of what I need, so it will not factor further. So that is my answer there. All right, we have our final 2. They're bigger problems. And then that's it. This is a good review of all factoring. Then we'll also be using factoring and solving by factoring with the zero product property, but we needed to review this first. First thing I'm going to do is look for a GCF, and it's just a 2m. And so what am I left with? I'm left with 125 m to the third minus 216. And the m came out. So the first thing I notice that I have 2 terms, I have a difference, and the other big thing is that m to the third, and that tells me, hey, this might be cubic. So I'm going to test my 125, it is cubic. I'm going to test my 216. And again, in case you need to see it in the calculator, you're going to type in the 3 first, and then second function in your x root key. It has to say the x root, and we'll put in the 125, and we'll see that we get out 5, okay? Same idea, type in the cube root of 216, and we get out 6. Some of your calculators have a math key, especially if you have a graphing calculator, so you would go into math, and they actually have a cube root in there, but you'll also see the x root option for higher roots we will use later. All right, so I'm going to jump into this. I'm going to set up my binomial and my trinomial, set my signs with SOAP, same, opposite, always positive. And now that I've done that, I'm going to take my cube root. There's your crazy root off, okay? There's your crazy root off, is taking the cube root and dropping it. So the cube root we said was 5, keep the m. The cube root of 16 is 6. Then the Santa plow snow is telling you to square the first term, the product for the second term, and square the last term. So if we square the first term, the mistake I see all the time is people say it's 5m squared. I need 5 times something to get me 125. So it's 5m times 5m is 25m squared. And then 6 squared is 36. And your plow is the product of 5m and 6. Again, we ignore the sign. It's a one time in math you ignore the sign because of the shortcut. So 5m times 6 is 30m. Again, this does not factor, but boy does this look like a perfect square. And if I try to do that, a 5m and a 5m and a 6 and a 6, I'll end up with a 60m, not a 30, but it does look like a perfect square. All right, one last problem on this. First thing I did was I looked for a GCF, and number-wise there is not one, but there's this extra k hanging out. So let's take the k out of there, and what's left is 64x to the 6 minus 125. So I have my k that's coming out, and then we are looking at this saying, so same, opposite, always positive. And the cube root of 64, if we type that in the calculator, we would find it to be 4. And we have x to the second. I need something times itself 3 times to give me x to the 6. So x2, x2, and x2. Then I take the 125, I take the cube root, and it's 5. I'm going to take my first term and square it, which is 16x to the 4th. So there it is. 4 times 16 is 64. X squared, x to the 4th is x to the 6. 5, negative 5, and I'm going to square it. So that would end up being a positive 25 here. And that makes sense. Negative times a positive is a negative 125. In the middle is that product. So we smash them together and we get 20x squared. Okay, now there's an x squared there, but the 5 does not factor down. So I'm good here. But if this is like a 1, then this would keep factoring. And this will not factor. Now the other thing I want to bring up, we're almost done, is that 64x to the 6, that could have been a square term, because 8x to the third times 8x to the third is 64x to the 6. What the determining factor was that it was a difference of cubes was a 125 is only a cubic number. Okay, well I really do hope this helps you review your factoring. It's really important and you use it through all the higher level maths, and we will see you again for the next lesson.